and it is an honor to be here with you at PyCon Philippines 2023. I was invited today to talk to you about the new features in the Python programming language. Today, I'm going to talk just a little bit about myself so you know why you might want to listen to me. So, I'm Mike. I write a blog. It's fairly popular called Mouse vs. Python, and I've written multiple books on the Python programming language. Sometimes I even create videos online that you can watch on YouTube. I've decided to talk about the new features in Python because a lot of people just don't know what kind of power there is in there and what the new features are in Python. And in fact, recently when I joined a new company and I was talking to my new coworkers, I would talk about features and they were like, "What are you talking about?" And I'm like, this feature's been in Python for a couple of years now. And so I just find it valuable to do some review and find out what you know about Python and what you don't know. So we'll start with 3.8. I just kind of chose that one arbitrarily. But I think that's when a lot of neat new features started getting added to Python. And we'll just work our way forward to 3.11. Now, I do want to point out that I'm only going to do some highlights of the Python programming language for each version. We're not going to look at everything because that would take multiple days. There are pages and pages and pages of updates in each new release of Python. So we'll look at some high-level highlights, and I'll do a couple of features of some of those highlights. So we won't be here all day. First off, we're going to look at Python 3.8. I've included the PEP numbers along here, so if you want to look them up later, you can. The PEP is just the Python enhancement proposal, and the number tells you which one to look at to get more information. So in Python 3.8, assignment expressions were added, positional-only parameters were added, runtime audit hooks were added, some C-related enhancements, and some pickle enhancements. We're going to focus on only the first two. So the assignment expression is a new syntax that was added to Python. It looks like you would use a : sign, and what that does is it assigns values to variables as part of a larger expression. It is sometimes affectionately known as the walrus operator, which you can see if you tilt your head onto your left shoulder and look at these two little dots. It kind of looks like eyes with some tusks underneath them. I don't know, that's what people say anyway. So let's take a look at how you might use this. So here we have the assignment expression, and assignment expression length of a greater than 10. What we're doing here is we're assigning the length of a to n inside of the conditional expression. This code will work if you have Python 3.8 or greater, and you can see that it worked because I'm able to print out the n value in this f string. Now if I change this to just a regular assignment expression and try to rerun this, you'll see that I get a syntax error. So to be blunt, you have to use the assignment expression in a expression or it doesn't work. So just keep that in mind. You probably won't see this a lot, but some places that I've seen that actually make sense for it is like if you're reading blocks of a file or downloading a file or some such, you can assign each block using the assignment operator in a while loop. Or I've also seen it used in a regex pretty effectively. So go check out the documentation. They have a couple of really good examples in there that make a lot of sense for that, but you're probably not going to use it a ton. It's just good to be aware of because the syntax looks a little different than what you might be used to in Python. Okay, speaking of unusual syntax things in Python, positional-only parameters were also added in Python 3.8. Here we have some oddball syntax. So from the 10,000-foot view, enlightening star args and double star keyword args for illustration, the grammar goes like this. Positional or keyword arguments are at the beginning. Star means that everything after the star will be keyword-only parameters. However, in Python 3.8, they added the ability to add just positional-only parameters at the very beginning. And to do that, you have to use a /. So if there's a / in the function definition, that means that anything before the / are positional-only arguments. After that is positional keyword parameters. And if you include the star, then after the star, only keyword-only parameters are allowed. The syntax is kind of weird looking. I recommend that you check out PEP 570 for more information and how you would use this appropriately. I've never actually seen this in production code as of yet, but I'm interested to see how people use this feature. Okay, so one of the other cool things in Python 3.8 is that they added a new f-string capability. F-strings now support the equal sign for self-documenting expressions and debugging. Let's check it out. So here we have a user, Eric Idle. He's been a member since 1975. And you'll see this funny syntax, f with a curly brace, the parameter, which is a variable, and then the equal symbol. What that means is that it will print out the variable as well as its value inside of the f-string. Super handy way to do self-documenting expressions and adding it to debugging. It also allows you to continue to use regular f-string syntax to format the strings that are inserted into the f-string. So you can, convert the user to a string if it happened to be something else. Or, that doesn't convert it, but *s or bang-s can make sure it's a string. And then, of course, you have the comma ID, which just adds a comma to anything over 1,000 in the output. Anyway, play around with it. It's a super handy way to enhance your f-string capabilities. All right, and then of course, I want to point out that there's a ton of improved modules in Python 3.8. I'm not going to go over these, but if you go in there, you can see that I'm nowhere near the bottom of the page, and it just goes on and on and on. There are a ton of awesome little updates to all your favorite modules, and so each of these that I'm going to talk about has that. They have pages and pages of little improvements. Some of them are incremental, some of them actually add new features to your favorite modules in Python. Okay, let's move on to Python 3.9. Here are the new feature highlights. They added union operators to the dict. Super handy, I'll show you why. Python 3.9 also started adding improvements to type hinting, and in my opinion, 3.9 is where the type hinting started to really shine because of these improvements, and they've added incremental improvements in 3.10 and 3.11, which I'll also be showing parts of later on in this presentation. They have a relaxed grammar restriction on decorators, which is really cool. I'm going to show you an example of that. And then they added some more string methods to Python to remove prefixes and suffixes. I won't show that one, but you're welcome to check it out in PEP 616. Okay, so first we're going to start with union operators added to the dictionary. If you want to merge dictionaries in Python, the old way to do it would be to create two or more dictionaries, and then to create the merge, you could use the dictionary syntax, the curly brace, followed by * dictionary name, comma, * next dictionary name. And of course, you could add additional dictionaries to this as needed, and it would merge it, like so. Nothing wrong with this syntax. It still works in Python 3.9, but they've simplified it by adding the union operator. So now, instead of doing the * or even the curly braces, you can just say a union operator B, and it does the exact same thing. Now, a lot of people ask me, what happens if B has a key that was also an A? So let's say we have another name here, and it's something other than Mike. So let's say it's Tobias. If I rerun this code, you'll see that name has been replaced with Tobia. I meant to write Tobias there. Okay. So why did that happen? Because in Python, the rightmost dictionary, if it has keys and that match the keys in the left dictionary or dictionaries, the rightmost ones win. It will overwrite it. So just keep that in mind. This isn't like a chained map like in the collections module, which will maintain the integrity of the dictionaries. It'll actually overwrite them. Okay, let's continue. Python 3.9 also relaxed the grammar restrictions on decorators. You can see the full details in PEP 614. Now, I don't remember what the details are about this, but because they did this, you can do crazy stuff like this. Ned Batchelder posted this on Twitter last year in 2022, and basically he added 3 decorators to a class. And what these are doing, in case you've never looked at decorators before, is that when you have a stacked decorator, you start at the one closest to the callable and work your way up. So this one here is creating a lambda that is going to grab the docstring of the class. So it's going to grab hello world. The next one uses Python string module, or string callable, and it calls its title method. So that's going to capitalize H and W, and then we added the print function on there on top of it. So when you actually run this code in the interpreter, it's going to print hello world with capital H and capital W. You can do all kinds of crazy stuff like this, do some parlor tricks in Python at your next Python user group, have some fun and amaze your Python friends. Okay, so type hinting generics in the standard collections. This is where the Python programming language has started adding better type hinting to itself. So, type hinting started in Python 3.5. And, they added variable type hinting in Python 3.6. And then nothing really happened, in my mind, that really helped make the typing simpler or easier to use. Until we get to Python 3.9, where they added dict, tuple, list, set, type, most everything in the collections module, and some other things in context lib and the regex modules. What does that mean, though? What does this slide even mean? So let's jump on over and find out. Before Python 3.9, if you wanted to type hint list, you had to do from typing import capital L list. And if you want to do dictionary, it'd be capital D dict or capital S set, etc., etc. And you'd write the code like this. That's fine and dandy, but it was always kind of annoying because I had to always remember to import stuff at the top of my Python module. In Python 3.9, it gets rid of the import. You don't need that anymore. Now you can just use the actual type to do your type hinting. So now I can use list, and it's happy, and I don't have to import anything. So now you don't have that overhead of the import of the typing module, and it just makes your code cleaner. All right. There are a couple of new modules in Python 3.9, GraphLib and ZoneInfo. This new module, GraphLib, gives you the ability to perform topological sorting of graphs, but it doesn't allow you to actually create graphs yourself. I'm probably not going to use this module, so I wasn't the audience for this one, but you should check it out, and maybe you are. ZoneInfo, though, I could see myself totally using this one. The ZoneInfo module brings support for the IANA time zone database to the standard library, which basically means you can add a time zone to your datetime objects and make them datetime aware. So here's an example. Here I am, I'm creating a ZoneInfo object. I'm going to do Los Angeles. This is going to make this object time zone aware and basically make it do daylight savings time. And then I use a time delta to convert it back to basically using standard time. So if I run this code, you can see that the first example prints out and it tells me that we are in Pacific daylight hours and then Pacific Standard Time after the time delta has been applied because I didn't reapply a ZoneInfo object to this date time. So anyway, what this does is it allows you to convert date times from one datetime format to another. So for example, I could have taken this and then created another datetime object and converted it to like Central Standard Time or Eastern Standard Time or some other datetime field because now it's part of Python. And I just see this as a really awesome benefit of being able to use this. Okay, of course, here we are again. There's a huge list of module improvements in 3.9. Go check it out if you want to see what else has changed. All right, let's go ahead to 3.10. A lot of people are excited that 3.10 came out because of structural pattern matching. When I first started doing Python, it was with Python 2.4. And I remember going to it and then, I just gotten done doing classwork in C++. I'd graduated like a year or two before and I started doing Python. I'm like, hey, where's the switch case statement in Python? And they didn't have it. And they haven't had it for my entire career until 3.10 came out. And now they have case match. It's not quite switch case. And it kind of does more pattern matching than you would expect in a switch statement. Interestingly, this one is actually defined across 3 different PEPs. So you have 634, 635, and 636, which I think is just a tutorial. Check those out if you want full details on this. I will show you a couple of examples, but it goes way more in depth if you go look at the PEPs. There's some more typing features added. The other big feature for Python 3.10 is better error messages and then some deprecations, because 3.10 is going to start warning you that the Python standard library will finally start dropping a few modules here and there to try to tighten things up a little bit. Okay, let's talk a little bit more about structural pattern matching. So first of all, this is kind of a generic example. This isn't real code, and this won't work if you run it, but it gives you an idea of how structural pattern matching actually works. Use the match keyword, you create a subject, and then each case uses a different pattern. And if it matches that pattern, the subject matches that pattern, then you perform some kind of action. The underscore is your default action. Okay, let's look at a practical example. Somewhat practical anyway. This one comes from the Python documentation, and I think it's also in that PEP tutorial I pointed out earlier, 636, I believe. So here we go. Match status. We have different cases, 400, 404, 418. If that status matches any of these patterns, then it will return a different string. And you can think of this last one, case underscore, as like the else and an if else statement. So let's run, oops, I jumped ahead. Let's run this really quick. You can see that it returns not found, so we hit case 404, which is what we expected. Structural pattern matching does allow you to combine multiple literals into a single pattern. To do that, you use that familiar union operator that we were looking at earlier. That union operator allows you to combine the literals. So here we're combining 401, 403, and 404. All three of these, if it matches any of them, it will return not allowed. Otherwise, we'll fall to our default case. There's a lot more information about this in the PEPs. Definitely check it out if you're interested. I highly recommend reading through it because there's a lot more that it can do. And there's also some good articles on structural pattern matching, both on real Python and in the standard documentation. All right, let's move on to the new type union operator. So you'll see that that union operator is starting to pop up all over the place. Before 310, you had to unite multiple types by importing this union object from the typing module. So let's say this number was an integer or a float, or it could be like a decimal type. You'd have to list them all out using the union operator. But now in 310, you can just use the union operator itself rather than importing. So again, we remove an import and we simplify the syntax. And you kind of see that's the trend with all these new versions of Python when it comes to the typing module. This union operator that's brand new, in 3.9 I believe, they've also added it to isInstance and isSubclass. So now if you want to test against multiple class types, you can use the union operator in isInstance as well, and that'll work. So one is, of course, an integer or a string in this case. And then lastly, in 3.10, we're going to talk about better error messages. So what is new? I really like these. I'm going to actually jump in there and just show you kind of what it looks like, because they actually show what the previous versions of Python's interpreter would do, and then what happens in 3.9. Now, I don't think this is a really good example because these aren't the same, it's not even dealing with the same object. But it does show that the syntax error is much more verbose and will tell you what's wrong with this particular example, even though it doesn't match the example above. So here, the expected was a dictionary, but it wasn't closed, so you get a syntax error. If you scroll down, you can see that it does a much better job of showing you what part of the code is wrong. The general expression needs to be parenthesized. Pablo did a lot of work on adding stuff like expected a colon here. Did you forget parentheses? Perhaps you forgot a comma. Just lots of this. And Pablo did a ton of these. This doesn't even show them all in this document. But it helps new people who are joining the Python programming language to figure out what's wrong with their code. And I think it will help a lot when you're debugging your code, because it's going to tell you exactly where the error is. So, give him a hand if you see him. Buy him a drink. He definitely deserves it. It's amazing. Okay, now we're ready for Python 3.11 before we run out of time. Python 3.11. The big deal here is that Python is faster. There aren't like anything huge and amazing in Python 3.11 except for that. They did add some exception groups. There's the TOML lib, which I will talk a little bit about. And they added some more error handling debugging stuff, which is pretty cool. And there's a little bit more type hinting features, and then some more deprecations. So let's talk a little bit about faster Python. Python 3.11 is between 10% and 60% faster than Python 3.10. On average, they measured a 1.25 times speed up on the standard benchmark suite. More information can be found here under which is the What's New link for Python 3.11. They go over what parts were made faster and how they did it to some degree. We're going to move on because I don't really have time to cover that. And, if you don't understand C code, you're probably going to be lost anyway. And I don't understand it a ton myself. So let's go to PEP 657, fine-grained error locations and tracebacks. Basically what this does is that it now marks where in the traceback something is wrong in your traceback, which is really helpful when you're debugging. So now I know exactly where to look in here. Before it would just say, we turn ABS and give all this code, and I'd be like, what is wrong with this code? And I'd have to put a breakpoint in and check each of these little pieces one by one. But now, because they've added these little carets, it points out exactly what the problem is. This example, I couldn't even get it to show right, so I'm just going to pop out of this really quick. And we're going to zoom in on this so you can see what I'm talking about here. So this particular slide, it's kind of a nested error, and it'll show you kind of where the problem is. And I like that they kind of did this wavy, and then they kind of pointed out this part is the problem right here. A really neat way to teach you what's wrong with your code. Let's go on. So lastly, we have the tomlib. I don't think this is quite the last slide. The tomlib, it is used to parse toml files, and that's all it does. So if you need to load a toml file or you need to load a string, that's what it does. There's some examples on here, and then the conversion table. If you need to write a toml file, you can't use this module. You'll have to install a third-party one. I show how to load up a string using loads, which is very similar to how the JSON module works, because JSON has a JSON load and a loads function, much like tomlib does. It just doesn't have a way to write it out. Okay, the last thing I want to talk about are the new typing features in 3.11. We're not going to cover all of these because there's a bunch of them, but definitely be aware of them. PEP 646, 655, 673, 675, and 681. Basically added a bunch of neat new little features to typing in Python. There's like a type to dict, which now allows you to set what is required and what is not required inside of the type to dict. So like this last one is only setting the year, which is not required, whereas the title one is. And so this is going to cause an error to get raised if you ever happen to use a type to dict. The other one that I thought that jumped out at me as being something that I'd probably use myself is the self type. And the self type basically lets you return self in a nice way. And before you had to probably create like a callable object from typing or create your own special function. And it would have been a much bigger mess to try to type this successfully. And so they just added a nice little shortcut called self that you can now import from the typing module and just clean up your code. Okay, so I know that was a ton of information, but I just wanted to thank you so much for having me here at PyCon Philippines and letting me tell you about all the new fun features in Python. All right, I'll talk to you later.
This is a question that I actually ask to everyone because I'm actually curious about their initial journey as to how did you get started with Python? I mean, how did you find your passion in Python programming? Because this is very general, but yeah, this makes a lot of sense for beginners who want to actually get started.
Yeah, well, when I first started doing Python, I'd been hired at a little government job, and the guy there was really passionate about Python, and he really wanted to transform all the code that they used there into Python. So, they did Visual Basic for applications, and they had some scripts that they used in Windows. And he was tired of Microsoft's updates breaking all the code because you might migrate to a new version of Microsoft Office or, upgrade the operating system. They'd have to redo a lot of code. And he was like, with Python, we wouldn't have to do that. And I was like, that's a really cool reason and a really awesome reason to do that. And you don't have to pay licensing fees either because Python's open source. Well, anyway, his passion was contagious. And I started reading it. I'm like, this is amazing. I'm actually understanding the code. because, in college and university, they taught with C++ and COBOL and C#. And I was kind of sort of understanding it. But then when I saw the Python code and it was so clear and readable, and it forced people to write it in a clear and readable way because it forces you to have spaces in your code and indentations. I'm like, this makes so much sense. I can read other people's code, not just my own. And then I met the Python community, and they were so helpful and so kind and helping somebody who doesn't know what they're doing. And, win-win-win for me. And so it just made me really passionate about it. And I guess I've just been that way ever since.
Oh yeah, this actually sounds similar to what I have experienced. Yeah, even when I was in college, they were like C++, COBOL, but then when we actually came to know about Python, it actually made sense, like a language which is making everything easy. And then, of course, the Python community that enhanced and helped us to go more and explore Python. Yeah, thank you, Mike. Yeah, makes sense. And yeah, we have questions from a couple of audience. Yeah, so we have questions. I don't think this actually looks like a question, but he's just getting it confirmed. So Sony says sets are basically dictionaries. Correct me if I'm wrong. So I'm right in heading that the use of the symbol was from sets, or was that a happy coincidence?
I don't know the history of how they chose curly braces versus square braces. But the way I think of sets is that a set is a kind of an unordered list without the duplicates, or without, yeah. So sets will remove duplicates for you. So, if you have a big list of items and you want to dedupe it, probably the fastest way to do that would be to turn it into a set. But then you lose the ordering of the list. So if the ordering is important to you, you could theoretically change it, do something with a dictionary. But then you have to watch out for those collisions that I mentioned in the talk, where, if that same key appears later on in the list, it's going to erase the original. So, there's a difference there because, the dictionary is a key value pairing, a hash table, so to speak, and the set is not. They have completely different methods as well. So I wouldn't call them the same, but you do have to watch out for that curly brace thing, because it can confuse you when you're first looking at it in a new code base. You're like, wait a minute, is that a dictionary or is that a set?
So yeah, Sony, I hope that clears your curiosity. Yeah, so this question is something even I wanted to ask Mike. So we have a question from Nino Mike. He asks, what's your most favorite and least favorite latest feature of Python?
Let's see, that's an interesting question. When they added the match case statement, I was like, why did they add this? And why is it so complicated? It sounds weird because a lot of people are really excited about it, but I saw that and I'm like, I was disappointed when I started with Python and then not being there, but now I know that the if, else if conditionals work fine. And the times that I've needed case match, I can use dictionary dispatch, which is basically creating a dictionary that can call functions, and use that instead of case match. And so right now I'm kind of, +0 on the whole matching statement. Do I like it? I don't know. Right now I'm stuck in Python 3.7 land at my current role. And so I'm not going to be able to use it for a while anyway. So it's another one of those cases where maybe someday I'll get to use it and I'll see its full power. But right now I'm not super excited about it. As for like favorite features, I really like F strings. I thought when they first came out, I was like, these are dumb. We have two other ways to format strings. We can use the %sign and we can use dot format. Why do we need a third way? That violates, the Zen of Python, which says there should be only one way to do something in Python. But F strings have grown on me a lot. And now they've improved it multiple times, so it's faster than the other two methods. So I really like f-strings now. They're probably my favorite feature.
Okay. Yeah, thank you. Nino, are you happy? Upstrings is his favorite new feature. So, oh yeah, we have a lot of other questions as well coming in, Mike, for you. So, yeah. Okay, we have questions from Yusa, and the question is, which new feature is most useful for you? Mm-hmm.
Originally, I probably would have said the f-strings, but now that I've been a part of two different large teams with large code bases, I've started to see the benefit of the typing module and how the typing can help, especially when onboarding new team members. It helps you to onboard people with various backgrounds into the Python code base quicker because they can just look at the code hints and say exactly what's going on. In my previous role, I worked with a lot of C++ programmers, and having the typing in there helped them a lot to understand what the code was doing, whereas before they would struggle. So I can see that as a huge win. I personally think it makes the code look a little bit uglier, but I can also see it has a lot of value. So I really like it.
Okay. So I hope that is answered. Yeah, okay. This question seems to be quite wide, going into other domains as well. So we have a question from Isuis. I'm sorry if I'm pronouncing it wrong. So the question is from Isuis. So the question is, what is the role of Python in terms of cyber or information security? Oh, wow.
That's not something I'm super familiar with, but
Okay.
I do know that there are a lot of people that are using Python for pen testing. So it's really big in that respect. They use it for that. My brother uses Python for configuring like Cisco routers and networking equipment. And that's kind of like the underlayers of the internet where security is important. So he's configuring stuff with Python in that way. Not quite the same as what I'm sure you're thinking of. There are also two really good cryptography packages for Python. You could probably use these to learn more about how you might use it, use Python securely with your code. I believe one of them is called PyCryptodome and the other one's simply called cryptography. So
Yeah.
that's about the extent of my knowledge, though, of Python in the crypto world.
Yeah, cryptography is something even I have heard of. A couple of my friends focus on that. Oh yeah, so I hope that answers your question. And we have another question. Okay, these questions are quite general, but really nice. Ben has a question. He asks, any predictions with Python language 5 to 10 years from now? Oh, you are actually a Python predictor now.
Yeah, so let me think about the future. Oh, I saw just this week that in Python 3.12, they're going to make it the global interpreter lock optional. So that's coming. That'll be cool. That'll help a lot with concurrency problems, especially in the data science and machine learning fields. And maybe eventually they can remove it entirely. I am still waiting for Python to get big in mobile development. I'm really hoping Kiwi will catch on, or that Toga will catch on, and that they'll do a lot better, or someone else would just come along. And I think PySide has or I should say the Qt framework has a mobile way of creating apps. If they just wrap it with PySide or PyQt, then we'd have something that looks native, and a lot of people already know. That's something that I'd love to see at some point.
Oh, so yeah. So Mike says it's something that he wants to see in mobile development in future. Oh yeah. Okay. So this would be the last question because we would run out of time, and the show will go on with the questions. So this is the last question, and the question is, oh, this is a bit long. It's from Andrian, and the question is, with all these new changes in Python, is it beneficial to apply the walrus operator in an existing project? Does it make it much more difficult to read the code with all these new stuff? Oh yeah.
Okay, so the walrus operator was designed for a really narrow set of use cases. I have honestly seen it maybe once in production code. So I think the use cases that are listed in the PEP for the walrus operator, that's where you'd want to look and see, do you have any of those use cases in your code base? If you do, it might be beneficial to add them. Is it going to make your code more readable? Maybe. I don't know. I don't think it's very readable myself. But if you've used it a lot and your other coworkers know what it means, then yes, go ahead and use it. It can shorten up your code base a lot. As for the second part of the question, does it make stuff more difficult to read? It can. Honestly, walrus operator, type hinting. I don't think the match case one really has a readability issues. I can see typing, especially because typing has changed like every single Python version. I can find that really confusing. If you can use the latest version, I think that'd be like your best bet. You try to use 3.10 or 3.11, and then you don't have as much to change. But if you have to support multiple versions of Python, it's going to make things more difficult.